record. So hello once again. Welcome to the third day of the third workshop for early stage researchers. This workshop is part of the EXtremeClimTwin project, and I'm really happy to announce our next speaker. It's Dr. Sophie Daloz from CICERO Institute in Norway, and she will tell us more about climate change and land. So please, Anne, the floor is yours.
Hi, Biliana. Hi, everyone. Thank you. Very happy to, not be here. Sorry to be online again, but very happy to do this lecture on climate change and land. And the idea of this lecture is really to take the multidisciplinary mindset that we often have at CICERO and trying to talk about climate change and land interactions, going really from the natural science point of view and getting on the impact on society and the socio-economic context. So let's see if we can move to the next slide. Yes. So this lecture will be divided in 3 parts. And the first one will be really more theoretical on the interaction between land and climate. And first really talking about land contribute to climate change, and then more the other way around, how climate change and human activities affect land. And then in the second part of the lecture, can you see my cursor? In the second part, we'll really go more on the societal impacts, talking about how it affects us, society, people, and also trying to talk a little bit about biodiversity, and also for getting in a more optimistic part of the talk, we'll also talk about existing solutions. And then in the last part, I hope we can have a discussion on what it means actually for the Norwegian or the Serbian context. And yeah, I hope we can all discuss that together. And I have tried to do this lecture a little bit interactive, so there will be 2 quizzes in the middle, very brief, very easy, but yeah, that will come at one point. So this lecture is largely based on an IPCC report that was released in 2019, which is called the Climate Change and Land Report. And it's part of a series of 3 reports that you might have heard of already in the previous lectures, but there was this 3 report, one called Global Warming of 1.5 degrees Celsius, the second one, Climate Change and Land, and the third one, the ocean and the cryosphere in the changing climate. And today, I will really be focusing on the second report on climate change and land. And this report is a special report of the IPCC, which talk about several topics related to land and climate change. So climate change, desertification, land degradation, sustainable land management, food security, and greenhouse gases fluxes in terrestrial ecosystems. I won't have time to touch all of these topics today, but I will talk about a number of them. So first, this first part more theoretical, more on the natural science point of view, looking at land-climate interactions. And this first part is really how land contribute or impact or participate to climate change. So I think you must have seen a version of this figure before, looking at human activity releases. So how the different activities that humans have and how it's releasing greenhouse gases and going in the atmosphere. And today we are really focusing on what's happening on land. So really on land and also a little bit inland, talking about sectors like agriculture, forestry, and other land use. So today, when we talk about these human activities and greenhouse gases, we'll have to talk about the sources and the sink. So for example, for CO2 or carbon dioxide, you can think about carbon sources or carbon sinks. So I will start first with the carbon sources, so a carbon source is the system that emits more CO2, as you can see here with the orange arrows. So it emits more carbon dioxide or CO2 than they sequester over a period of time. On the other hand, a carbon sink is actually sequestering carbon in the soil, in the forest, in different ways. But we'll talk about that a little bit after. We'll talk first about the sources. And one more thing that is important to realize before we go even deeper in the sources is to realize that, of course, when we talk about greenhouse gases, we tend to talk a lot about carbon dioxide, or we tend to hear a lot about carbon dioxide, but there are other greenhouse gases that are very important to consider. And I think we hear more and more about methane emission, nitrous oxide, and it's very important not to look only at carbon dioxide when you think about greenhouse gases emission. And I will tell you a little bit more here why we talk a lot about, or we have talked a lot about carbon dioxide, but we are looking more and more into methane and nitrous oxide emissions. So here, the green, these green rectangles show you the amount of greenhouse emissions in 2018, and then we'll talk about the global warming potential. But here, these green rectangles are just showing you how much carbon dioxide here you have in the atmosphere in 2018, and then how much methane, and then how much nitrous oxide and fluorinated gases. And you can see that you have much more carbon dioxide in the atmosphere than the other greenhouse gases. So that's, of course, one of the reasons why originally we have heard so much about carbon dioxide and maybe less about other greenhouse gases. But then you need to look at the characteristics of these greenhouse gases, because they are not impacting the atmosphere the same way. So in this case, you can look at what is called the global warming potential, which is a metric, so GWP, that is used by many people working with climate issues. And here you can see that I don't know if you see here, but the global warming potential of carbon dioxide is 1. It's taken as a reference. But then for methane, it's between 27 and 30. So that means that methane is warming the atmosphere 27 to 30 times more than carbon dioxide. And then if you look at nitrous oxide, it's even bigger, it's even higher. It arrives to 273 times. I mean, it's an estimate, but you can see that although you have much less methane and nitrous oxide in the atmosphere, their potential to warm the atmosphere is really important. And that's why we really need to think about all these greenhouse gases together when we think about greenhouse gases emission. And just a little bit more about this global warming potential, because it's cited in a lot of research. And it doesn't only talk about, so it's a combination of radiative efficiency, so the ability of a gas to absorb energy and radiate it. But the second part of this global warming potential is about the atmospheric lifetime. So the time the gas will stay in the atmosphere. And when you think about mitigation, it's also very important to think about how long the gas will stay in the atmosphere if it's different. And on the right side here in the table, you can see that carbon dioxide will stay around 100 years in the atmosphere, while methane will stay around 10 years in the atmosphere. And then nitrous oxide will stay around 120 years. So when you think about mitigation, there's been a lot of discussion about methane mitigation, because if you do mitigation on methane, the impact is maybe quicker than on carbon dioxide. So it's very important to have this discussion and keep that in mind. And when we see the next slides. So now let's go more concretely into the sources of greenhouse emission from land. And in this case, in the land report, you need to look at emission from what we call FOLU, so agriculture, forestry, and other land use. And the leading cause of greenhouse gases released from the land come from human activity, which is not surprises, but it's important to keep that in mind. And globally, 23% of global greenhouse gases emission released in the past decades come from agriculture, forestry, and other land use. So if we want to mitigate greenhouse gases, it's of course very important to think about these sectors: agriculture, forestry, and other land use. And the major driver of CO2, of carbon dioxide release, is deforestation and other type of vegetation loss. And CO2 emissions from land use have stabilized at high level over the past decades. So although they are high, they are staying at the same level. And it's also important to think about that, because when we look at other greenhouse gases, it might not be the same. A major source of methane emissions come from livestock, so ruminants, but also the expansion of rice cultivation. And when we look at the methane emission from agriculture, in this case, they are not stabilized. They have increased by 1.7 times since 1961. So that's why it's really important to not only think about carbon dioxide, because methane emissions are increasing. So they will have more and more impact on our climate. And the same for nitrous oxide, because you have more and more nitrous oxide emissions. They come from agriculture and the application of nitrogen fertilizer. And same as methane, they have increased a lot. They have doubled since the 1960s, if we look at the land report. So really, it's important, again, to think about not only carbon dioxide, but other greenhouse gases emissions. So now going into the things, you have different ways in the nature to actually store carbon and to sequester it. And you can look at land ecosystems, the Earth deep mantle, and also the ocean, and of course the atmosphere. But of course, they have these systems, these things, they have a limited capacity. So they can store some carbon or some greenhouse gases emission, but they can't store everything. At one point, what will remain will go in the atmosphere and of course warm the atmosphere. So an example of a sink, an obvious one, is forest. And actually 45% of carbon is stored inland by the world forest. So of course, that's why there is a lot of discussion currently and in many countries about afforestation, deforestation, and the management of the forest, because they are very important for as a sink and also for other purposes, of course. But in this discussion about land and climate and greenhouse gases emission, forests are very important. And the soils also, which actually I didn't realize before starting working on that, but soils hold a large part of the carbon. If we look at the top meter of the world soils, and apparently it contains 3 times as much carbon as the entire atmosphere. So there are different processes. So through plant material, crop residue, and animal manure, but the soils, just the first meter of the soil, is very, very important for as a carbon, as a greenhouse gases sink. So that's the first part of the first part, and now we can go on the impact on from the climate to the land, so on the other side. And if you have any question, please stop me. I didn't think about saying that before, but you can stop me on the way. So this part, I think we've talked quite a lot about it. I mean, indirectly, but I think we have had quite a lot of discussion about climate change and extreme events, of course, in EXtremeClimTwin. But so I'll go quickly. But I mean, as you can imagine, how would climate or climate change impact land? Well, through changes in mean temperature, precipitation, rain, snow, of course, all that will impact land in different ways. But then, of course, you have also the changes in extreme events. And an important topic now in research is the cascading compound events, the way that you can actually have not only one extreme event, but you can have several extreme events that can be triggered, for example, triggered by another one. So, for example, you can have extreme precipitation, which will trigger floods. And of course, that will have devastating impacts on land and different sectors. So that's a major topic in research now. So of course, yeah, I was just showing some example because I think we already see some of these events happening around us. I put some example here in Canada, in Germany, in Sweden, but it's everywhere. In the past couple of years, I think we see more and more on these events happening and impacting land in different ways. So in the climate change and land report, they are even more specific on the impact of climate change on land, and they talk about land degradation and desertification. So that's where I have a little short quiz or question. And I will first tell you what is land degradation or the definition. And it's all negative changes in the capacity of the ecosystem to provide food and services. That's the definition from the FAO. And now my question is, how much do you think of the Earth's ice-free land area is already now subject to human-induced degradation? So I have some options. So it can be 5%, 25%, 45%. And I guess you could write it in the chat. I can't see the chat in this setup. I don't know if I can. Maybe Biliana, can you write? And then I guess you can all tell me orally what you think is the number or just write it in the chat, but I can't access the chat for some reason.
We said 45.
45? So you're even more pessimistic. So not yet. It's 25%. So it's 1/4 of the Earth's ice-free land area, which is subject to land-induced degradation. But 1/4 is already a lot. I mean, a quarter of the land that is already subject to human-induced degradation, it's a lot. And just to give you an idea more concretely, economically. So for example, it's estimated, I am giving here, sorry, some example of land degradation, which can be wind erosion, water erosion. That's some typical example of land degradation. And it's estimated that the total annual cost of erosion from agriculture in the US is costing $44 billion per year. So it's a huge burden everywhere, and of course it won't get better in the future if we follow the same path. So they not in a more optimistic note, actually, we can also look at desertification, and desertification is a form of land degradation. Is when you have an irreversible change of the land to such a state that it can no longer provide its original use. So for example, here you see a field for agriculture, which become a desert. And then of course you can't use it anymore, and because nature won't be able to come back. And 500 million people live in an area which experience desertification. And there are some reports that also say that if we continue on the same path, 2/3 of Spain could become a desert by the end of the century. So that's very concerning, especially if you think about Spain, that is providing a lot of agriculture for Europe and other places in the world. That's really a big issue. So that's the first part, which is very pessimistic, but please stay with me because we have some optimistic things coming after. And yeah, I just tried to give you a summary of the point that I would like you to take home. So I think it's really important that greenhouse gases emissions are not only about carbon dioxide. There are other greenhouse gases that we really need to look at and consider when we think about greenhouse gases emissions, like methane and nitrous oxide. And yeah, we have talked about agriculture, forestry, and other land use and how they are related to these greenhouse gases emissions. And it's also important to remember that land is both a source and a sink in terms of greenhouse gases emission. And then, of course, the impact of climate change on and human activities on land, including extremes. That is really an important topic in this project in EXtremeClimTwin. So now we can go in the second part, which is much more applied, where we go really on the impact on society. How is it really linked to our day-to-day life? I mean, we've seen agriculture, which of course is related to what we eat and our day-to-day life. But I would like to go more concretely about how it's affecting us. So, for example, in the land report, they talk about food security, land use conflict, and there is also another report that talks about biodiversity, and I will briefly mention it. So I will start with another little quiz, very quick, on food security. So how much do you think, how much food in the world every year is lost or wasted how much of the food produced is lost or wasted. So your three choices are 5%, 15%, or 30%. What do you think? Are you?
I go for the highest, 30.
Manfred, 30. Liliana?
We also think 30%.
Well, this time you're right. Unfortunately, 30% of the food we produce is left or wasted. And I actually checked in Serbia, and in Serbia, 770,000 tons of food is wasted or lost in Serbia. And I looked at for what it means for individual people, and even in tons, it's really huge. I mean, it's everywhere, but I think it's a part that is really hard to swallow, at least for me, because the food system contributes to 30% of our greenhouse gases emission, and in the same time, we waste 30% of the food we produce. And I think it's really unacceptable. And also thinking that food is really something that is a trigger for strong social inequalities in the world. So you have 821 million of people that are undernourished, while 2 billion adults are overweight or obese. So there is no way. We have to do something about the food system, not only actually from a climate point of view, but also because the impact on society is huge for many different reasons. And climate change, the issue also is that that's where we are now, but climate change is impacted the food system in many different ways. So that won't get better in the future. So climate change is impacting, of course, the yield, the crops. It's impacting food safety, the food quality also. If you have heat stress on plants, they can be less nutritious, for example, and it's of course impacting livestock. So all that is will be even more a problem in the future in terms of food security. But I just want to mention quickly that there are different paths. So if we look at, I think we've talked already about the SSPs. So the different paths we can have in the future, more optimistic or pessimistic. So here you can see the different paths, and SSP1 would be with more engagement from society and from government and more action on climate change. And SSP3 would be the more pessimistic path. And if you look at these colors, if you are in yellow, you're staying in a moderate impact, while if you go in darker colors, it's a higher impact. And for food security, we can clearly see that depending on the path we take, the impact will be very different in terms of availability, access to food, and many other things. So there are really options that can be really better or worse for the food system and other systems, of course. But now I'm focusing on food security and insecurity. So now the more optimistic part. There are solutions, and actually there, I mean, of course, we don't have all of them, but there are solutions that already exist. We can, for food, concretely, we can work on our consumption practices, on our diets, on food waste and loss. And for example, here, I give an example of the LAN report where they talk about the different diets and how it impacts our climate. So of course, you have the vegan diet, which is it's the best for the climate, but I can understand that it's not necessarily easy for everyone to become vegan. So you have other options, and I'm giving the examples of flexitarian, where you're still eating some amount of meat and fish, but you reduce it, and also you reduce all the sugar part, but you eat more fruits and vegetables. And I think what's interesting about the flexitarian diet is that you already have quite an important positive impact on the climate, but also on your health. And I think it's a little bit more approachable for many people in society. Of course, if you want to be vegan, great, go for it. It's good. But I'm just trying to bring other options that are more attractive, maybe for some of us. There is also the possibility of reducing food waste, and I think it has already started in many countries where the distribution of food surplus is given to groups affected by poverty, or the conversion of food to animal feed, or recycling food waste to produce energy. So it's a real solution that are possible to implement in many countries and are actually implemented now. So there are really options to work on the food systems. And now the other topic, I think it's the last one. It's land use conflict. It's a big topic now, and I think I will try to illustrate why it's so important. So for example, if we talk still about food, so we have an increase in population, so we need to feed more people. But at the same time, with climate change, you might decrease your production in crops because extremes or mean temperature, for many reasons, you might have a decrease in crop yield and issues with agriculture. So one idea would be to say, okay, we just, if we don't have enough crop production, we just increase the space where we have agriculture and then we have more food. Except, I mean, that's limited because we can't do that everywhere. I mean, for example, in Norway, we really have a limited space where we can grow food. So that won't get us very far. And also at one point, we won't have this option anymore. We can't extend land. And then the other part to consider is that, of course, with land, you're not only providing food, like each countries have to think about these international and national goals in terms of climate and biodiversity. So with land, you also need to produce renewable energy. You want in Norway, for example, to take care of the forest, and then you have agriculture. So you have a number of things that you need to do with land, and that can bring a lot of conflict in the different countries because each sector will have its own interest, and that might not be in agreement with the other one. And that's a current discussion, I think, in many countries, or even at the regional level. So yeah, I'm arriving to the end and arriving soon to the discussion, and I just wanted to highlight that there are big issues and challenges coming, but there are a lot of solutions that exist, and in the land report you can look at them for different sector subject, and they really talk about a lot of solutions that can be already implemented. And of course they emphasize the fact that it would be very good to have solutions with co-benefit. We can't only think about climate or about health or about biodiversity. We need to bring all that together. And I also just wanted to mention that you have this report on biodiversity, because biodiversity is also quite a central topic in research now. I mean, there was always research about the biodiversity, but I think there is a better connection between biodiversity and other disciplines now. And I think it's very important. So the summary of this part is that we have an issue. Land is under growing pressure due to land use conflict, climate change, and many other things. But really, land is part of the solution. We really can do a lot if we think correctly about land with afforestation, renewable energy, and many other things. But clearly, land can't do it all. So we need, our governments need to do their part. And the change in diet or consumption or food waste is very important. And for the last part, I was thinking, I think it's nice to, because that applies to Serbia too. I mean, to many countries. I've had this discussion in Norway before, and I was thinking that it would be nice to have your point of view for Serbia. Do you think the issue of food security exists in Serbia? And then do you have land use conflict issue growing or already existing? And I just wanted to give you, that's for Norway, but we can talk about it or not. I looked a little bit in the, I looked for information on Serbia, and I saw that a large part of your greenhouse gases emission come from the energy sector. And at the same time, I mean, it's 80%, it's huge. And then at the same time, agricultural land occupies 65% of the total area of Serbia. So clearly, and I saw that the government is trying to transition from, I guess, some combustion or fossil fuels emission or fossil fuel energy to more renewable energy, but you need space for that. So then I imagine you can have maybe a conflict with the fact that you have a lot of agriculture and it's an important sector in Serbia. And So that's just yeah, for opening the discussion, some facts about Serbia, but yeah, I hope we can have a discussion about that. I'll stop sharing my screen if I can do that. Yes.
Okay. And Sophie, would you like to discuss now about the food security in Serbia and greenhouse gas emissions here or later?
So I was thinking now, but what do you think we should take a break and do it after? What I mean,
yeah, we can have 5-minute break.
Yeah.
To make some coffee.
Sounds good.
Okay, so we will be back in 5 minutes. Okay.
Yeah, sounds good.
Would you like to? No. Okay. Well, the same one as yesterday, or?
Yeah, that was nice. Yeah.
On the topic, just give me 1 second. This one?
That one and the one with the greenhouse gas emissions from Serbia with the energy
Okay.
sector, agriculture, etc. So
yeah.
Yeah, this one. Yeah.
And I guess this can be discussed for also England and Germany if Manfred and Rob wants to participate.
Yeah, actually in Serbia and Southeast Europe, I read a report about the climate change in Southeast Europe, and there you can see, actually you can read that Serbia and this part of Europe is dependent on fossil fuel usage for the electricity and heat production. So the majority of electrical power and heating in Serbia comes from the burning of fossil fuels, coal mostly. But there is another report issued maybe a few months ago that says that Serbia actually invested the most into the renewable energy in the Western Balkans. So I think there is some steps, you know, to have more greener energy here in Serbia, but still it's in the beginning and it's really early to see the effects of that. So.
Yeah, I mean, I think it's a good point, but I'm just also thinking that, of course, there is this step, but that's just thinking about the energy sector. Then you'll need to put renewable energy somewhere. And at least in Norway or in France, I can see how, for different reasons, for example, there are tensions with the agricultural sector, but also for tourism and social acceptance. So it's not always easy to transition one sector, and it's usually bringing tensions with others.
Yes, I also think it takes time to transition or to include the greener energy into an energy system. And also about the agriculture, I can see that the most greenhouse emissions from agriculture comes from synthetic fertilizers and the use of the synthetic fertilizers. So does anybody have any idea about that? Because we have people here from Biosense Institute, the institute that deals with the agriculture and its impact on climate and climate impact on agriculture. So if anybody has any question or comment, please
feel free to say something.
And Manfred, did you want to say something also?
I'm just listening. I can later make a few comments on Germany, but go ahead first with Serbia.
No, Manfred, please, because people here are really reluctant to comment. Yes, please, Manfred.
We know about the climate problem, and we know also then about the war between Russia and the Ukraine. Therefore, in many countries, also in Germany, we have a lot of discussion about energy, the way we produce energy, and the discussion whether we should wait a bit with the phasing out of nuclear power plants, and whether we should use again coal and not. There are many different values associated, and it's not easy to find a good solution. But I think on the longer term, I mean, in the order of a couple of years, a few years, maybe to 5 or 10 years, there's no way to do it without renewables. And the sooner we learn and have the ability to research on that, the better.
Yeah, I agree, and I also agree that the renewable energy, and also we bring together all these solutions between the different sectors, because it's very complicated to use land in a smart way. I mean, I have the example I can show you of Norway, but Norway is just mountains. So then the potential to grow food is, for example, very limited. So you need to be very smart about how you use the land that can provide food, and then how you use the land where you can have renewable energy, and there is quite a lot of tensions about that. And also the fact that, for example, in Norway we import 60% of our food, so we are very dependent on other countries.
Maybe if you allow, Sophie, since you have knowledge about the forest and the carbon source and things, I'm currently reading two books about forests and whether they have the ability, yes or no, to act as a long-term thing. I myself, as an environmental physicist, I only recognize carbon cycle is rather complex things, and you have to think about in terms of different time scales. It may be in short term a thing, but in the long term, I don't know. And what's your opinion about the longer term effects of forests? Do they act as a sink? Do they really store the carbon, and will it be released into the soil for long? I speak about centuries and millennia.
So that's a very important topic. I mean, you can imagine that in Scandinavia, where we have a lot of forest, that's a very important topic. And I think, I mean, I'm still like you, trying to understand more and more about this topic, because it's very complex. From what I understand, also you have different scales. So young forest, older forest, also the combination of forest. I mean, there are a lot of things that enter in the fact that the forest will store carbon or greenhouse gases. And from what I understood, one of the issues also, it's depending on the lifetime where the forest is, young, old, the storage, the ability to store carbon will be bigger or smaller. So I think that's why some people are also talking about the management of forests, actually to work with the forest to have the full potential of the storage. So I think, yes, forest is a thing. I mean, but there might be different ways of taking care of the forest to have the full potential. But it's I agree, it's a very complicated topic. I'm also reading a lot on it currently.
Yeah. Because a comment, maybe there exists also other interests, namely making money out of the wood, and therefore the opinion of the forest managers in terms of carbon cycle. And so I'm not sure whether they really are the experts, and whether they have not their own interests, which then influence their assessment.
Well, I think it's like many topics around climate change. The issue is that you need to look at a different point of view, because I think like now we have more and more projects on that, because there is also the point of view of biodiversity. depending on how you manage your forest, biodiversity will be better preserved or increase or enhance. So I think it didn't used to be such a big topic, but I think now we are looking at it from different lenses, and I think that's what we need, because I agree that at this point we have some knowledge, of course, but we need more knowledge, because we need to take these solutions to have these measures about land and forest is really part of the question.
We have a comment in the chat.
Oh, okay. I can't see it's. I don't know why I can't see the.
Comment, maybe you could.
Oh yeah, no. Okay, now I think I can
speak,
see.
or I can read, which is easier. Comment on Serbian energy. Our government tried to switch to more green energy 3 years ago, but I find it very wrong. They planned to put 600 hydropower plants on mountain rivers, which do not have the capacity to run entire year. Basically, our mountain ecosystems would suffer the most, as the water would be locked in pipes. People living in these areas had a lot of protests before the government decided to give up on this silly plan. These 600 small hydropower plants would contribute only about 1% to existing system.
So I think it's a very good comment, and I mean, I don't know enough the context to really judge, but at least I can comment on it, because I mean, it can be hydropower or renewable energy. I mean, there are really good solutions, and they will provide green electricity, and they have a lot of positive things in terms of the climate. But I think now we are seeing more and more that if you want to have solutions, they need to be socially accepted, which is not necessarily easy. But also you need to think about biodiversity, ecosystems, and some of these solutions sometimes are political. So you show that you have implemented renewable energy or hydropower, and you don't do it really in a smart way, in the sense that you need to talk with the population. You can't. I mean, we have a lot of work in Norway about that, where the solutions need to be implemented in consultation with municipalities, with stakeholders, with local population, because you need to find solutions, basically. I mean, it's the same for food in general. If, for example, you decrease livestock, so if you have less meat produced, there people will lose their job. So you need to think about what they will do. So it needs to be concerted, and I think you need to think about what's happening for people if they need to move somewhere else. So I agree, it's a good comment, because it's very complex, and the consultation with population, I think, is I mean, you won't always agree, but you need to have this discussion.
So everybody needs to be in a good position when concerning the land use and climate change.
At least I mean, of course, it's difficult to please everyone. It will be very difficult, but at least we have seen that I think in Norway or other places, the consultation with the municipalities or the population, at least you can reach a consensus. It's not perfect, but maybe you can agree on something that works better for everyone. And sometimes it might be very difficult, but it's important to think about the livelihood of people. What will they be able to do after? So yes, social acceptance is a big issue in this transition in general.
Rob has a comment.
Yeah.
Thanks for that presentation. Just a couple of comments, really. One is perhaps a factor that you hinted about, which is the supply chains. So climate change impacts supply chains, the supply chains impact climate. So that might be something else to throw into the mix. One good example of that I came across recently is that to import a single red rose from overseas to the UK costs about 2.5 kilograms of carbon. But that's nearly 10 times the amount as if you took the same rows or similar rows grown domestically. So the impact of supply chains from far and wide can have a huge carbon footprint relative to more locally sourced produce. That scales up across all the things that we consume, whether what we wear, what we eat, what we dress our houses with in terms of flowers. So I think supply chains is an important part of the conversation as well, keeping them as short as possible.
So can I comment already on that? Yeah, just because we have done research on that, and that's interesting because, of course, if you think about mangoes coming flying with a plane, the impact on the greenhouse gases emission cost is huge. But for example, the food that comes by boat, I mean, for example, in Norway, we import 60% of our food. So you can imagine how much the supply change is having a huge, it could have a huge impact on the greenhouse gases emission of our food system. And actually, it's not that much. It's a small part. The really biggest part is what we eat, like if it's more plant-based or animal-based. And I think, but that doesn't mean that I don't agree that we need to reduce the we need to eat more locally. But I think from what we see, it's not so much about the climate for a climate reason, but more for the environment, biodiversity, and local producers, and ethics, and many other reasons. But that shows again that you can't only think about a climate point of view. You need to think more integrating other aspects. So I don't disagree with you, but I'm just saying from what we see, it's not purely from a climate point of view. It's more from other aspects.
Yeah, I completely agree that I think this more holistic approach. So you look at the trade-offs of the local environment versus the distant environment, the local economy versus the distant economy. And so absolutely, I think it has to be a more complete assessment. But I think that the supply chain thing is something that hasn't really been looked at so much in terms of its susceptibility to climate change and disruptions there. The second point I was going to make is an interesting and surprising study that was published, I think, about a month ago, linking food security to climate change in a way that you probably, or many of us may never have imagined, which is that as the energy industry shifts away from fossil fuels and desulfurization, there could be a coming global scarcity of sulfur, which is an important part of fertilizer production and a very important ingredient in all sorts of manufacturing processes. So there are all these sort of surprising connections between the mitigation agenda and how that could still feed through in unimagined ways to food security and industrial efficiency and production.
That's also a good point. And I think so in the research we do currently, we are trying to work on multi-sector level, because you have this relationship that sometimes you don't think about. I mean, I think in the past we have tended to look at agriculture, forestry. I think it's good sometimes, as you say, to bring stuff together, because there are these connections that you didn't think about before, but then sectors are connected in a way that you really need to think about it before making some choices.
I think the kind of tools that we need to address these bigger connections is the integrated assessment tools, which connect not just the climate, the economy, and the environment, but wrap in all of these other factors to help us see this bigger picture.
Yeah, I agree, and we use some of them, so that's why I totally agree with you. I mean, we have some projects now about multi-risk, multi-sector, so really trying to bring things together and think about these connections also, not only seeing what's happening in the end, but how the energy sector, I don't know, tourism, transport, because transport is also a big part. Food, but how do you have this link? Why are they so interdependent?
Any other comments? Nothing in the chat, so Sophie, please continue.
And if you have questions, if something is not clear, normally I should have my email at the end of the presentation. So feel free to send me questions or yeah, comments. Oops, I think that's all I have for the lecture.
Could you please show us about Norway? You said that there is a case study similar to the one we discussed for Serbia. Can you tell us about?
Yeah, I'll share again the screen.
Yes.
Sorry. So I think I think so when we think about these land use conflict questions or food security or all these questions, of course it's good to think about it globally because we need to work on it together because we depend on each other. But it's also good to think about it locally because we have each country have their own specificities. For example, in Serbia, you have 65% of arable land, which for us in Norway, it's crazy. I think we have 10 or 15%. So because as you can see, Norway, it's all mountains and here the red or orange part are where we can grow food on this map. So it's really not a lot because then the rest is mountains and also some land are just not good for growing food. And then we have the climate. In winter, it's snow. So you won't grow or not much in Norway in winter. So then that means that, yeah, and then we have global warming coming, which could have a positive impact in somewhere. We could grow for a longer time, but you have also extreme events. I mean, it's really hard to know if that it will be that positive for Norway. There is actually work on that. So yeah, you have all this impact on land, which are not, which we don't really know if, how it will turn out. But then in our case, we import 60% of our food. And I think many people in Norway don't realize how much, if climate change is impacting India, I don't know. And if there is the issue, other conflicts also with Russia, Ukraine, whatever, then we are really in a complicated position because we rely so much on other countries that even if sometimes we are not so much impacted by climate change directly, but indirectly, that can have a huge impact on us. I mean, for example, now in Norway, we have the issue, like many countries, of the price of energy, but then you also have the price of food. And when you import 60% of your food, I was showing some newspaper in Norway, and already last year they were saying like why food in Norway could become even more expensive, and it's becoming more expensive clearly. So it's very different context from yours because our energy, I mean, it's completely opposite because basically our energy is mainly, the electricity is mainly green. We have hydropower, but then we have agriculture, not so much, but it's a part where we really need to work a lot on, and then we need to import a lot of food. So it's completely the opposite from Serbia, but that shows that you can't have the same solution for every country. You really need to think about the context and and how you can make it work with the different sectors. So that's just to I thought it was good to have very different illustration of what land use conflict means or food security means in different countries.